It's Algebra 1, Test 14 through Section 2.6, Inequalities, Study Guide. Solving these inequalities, first thing you need to do is distribute. Now put all your y's on the same side. Get rid of positive 4y by subtracting it on both sides, and you have 6 plus 6y when you subtract 4y from 10y. Get rid of positive 6 on both sides by subtracting it, and you have 6y is greater than or equal to 18. Then get rid of 6 times y by dividing on both sides. Y is greater than or equal to 3. Put all your p's on one side. Let's move them all to the left to where we keep our variables on the same side. Subtract 20p on both sides. 13p minus 20p is negative 7p. And you could have gone the other way as well. Put negative 10 over to the other side by adding 10 to both sides. Negative 7p is less than or equal to 28. Then get rid of negative 7 times something by dividing by negative 7 on both sides. P, 28 divided by negative 7 is negative 4. Since we divided by a negative number, we have to reverse that symbol to say greater than or equal to negative 4. Distribute negative 2. Combine your like terms at this point. N and negative 2n is negative 1n. 4 and 36 is plus 40. Get rid of positive 40 by subtracting it on both sides. Negative n is greater than negative 40. Get rid of negative n times something by dividing by negative 1 on both sides. N, negative divided by negative is a positive. We divided by a negative number, so we have to reverse the symbol to say it's less than 40. Suppose you had $D in the bank account, you spent 18. Spent 18 means you went down 18. But you have at least 60 left, at least greater than or equal to 60. How much money did you have initially? So D dollars in the bank. So D minus 18 has got to be greater than or equal to 60. So D minus 18, because you spent 18, your D was your initial amount, has to be greater than or equal to 60. That's at least means greater than or equal to. So there's your solve. Right and inequality. Now we'll solve it. Add 18 to both sides. And D has got to be greater than or equal to $78. That's what you started with originally. That's your initial amount. Hope to collect at least 300, at least greater than or equal to 300, at least. 119 cans donated the first week, 112 the second. Right, and inequality that describes the situation. So week 1, 119 plus week 2, 112 plus week 3, that's the unknown amount. Let C represent the number of cans the third week. Has got to be greater than or equal to 300. How many cans are needed to surpass your goal? Combine these two. 231 plus C is greater than or equal to 300. Get rid of positive 231 by subtracting it on both sides. So C is greater than or equal to 69 cans. Sponsor on the bake sale, at least $140, greater than or equal to 140. 350 each, so 3.5 times X. So 3.5 or 350 times X has got to be greater than or equal to 140. So divide by 350 on both sides. And X is greater than or equal to 40. So they have to sell at least 40, so 40 or more. Graph this inequality. It's positive 1 or equal to means colored in. Less than means go that way. You can look at it as the arrows point you that way. Right, in inequality for this one, we have negative 7. So we have X and we have negative 7. because that's the number that's represented between -8 and -6. It's an open bubble, so it's not going to be or equal to. It points this way, so that means it's going to be x is less than -7. A number exceeds 69. It's not 69 or more, or it's not at least, it's exceeds. That means more than. So x is greater than 69. Get rid of plus 20 by subtracting it on both sides. You get -7 equals -d. Get rid of -1 times something by dividing by -1 on both sides. Negative divided by negative is a positive. Distribute 4 times y and 4 times 5. Get rid of plus 20 by subtracting it on both sides. 4y equals 28. Get rid of 4 times something by dividing on both sides. Y equals 7. Get rid of plus 25 on both sides by adding 25 on both sides. 2p over 6 equals 8. Get rid of divided by 6 by multiplying by 6 on both sides. 2p equals 48. Get rid of 2 times something by dividing by 2 on both sides. Solved in graph, undo -3 by adding it. X is less than or equal to -2. When you graph that, negative is on that side of 0. Less than or equal to means color it in. Less than means go that direction. Remember, this can be read different ways, but x over -4 is the fastest way to read it, because we can cancel out divide by -4 by multiplying by -4. Do the same here. 2 times -4 is -8. X, we multiplied by a negative number. This has to reverse and be called greater than or equal to -8. Again, 0, -8 is over here. Or equal to means color it in. Greater than means go that direction. Get rid of 5, divide by 5 by multiplying by 5 on both sides. Negative times positive 5 is -25. So x is greater than or equal to, no reason to reverse the symbol. Graph that, zeros here, -25s on that side. Greater than or equal to means color it in. Go that direction. Get rid of 9 times something by dividing. X is greater than or equal to -1. No reason to reverse it because it was by a positive number. 0 and -1. Greater than or equal to, color it in, go that direction. Get rid of -11 times something by dividing by -11. Negative divided by negative is a +2. We divided both sides by a negative though, so we have to reverse the symbol. Greater than 2. Open bubble, everything that way. Okay, these are compound inequalities. Now instead of having a left and a right, now you got a left, a middle, and a right. So whatever you do to the middle, ultimately you're trying to get x by itself. But whatever you do to the middle is what you got to do to both the left and the right. Get rid of -4 by adding it. If you add it there, add it to the left and add it to the right. So -4 plus 4 is 0. Then get rid of 2 times something by dividing by 2. Divide the left by it and the right by it as well. 0 divided by anything is 0. Then we have x. 14 divided by 2 is 7. We didn't do anything to reverse the signs, so we'll leave them both as less than. As a compound inequality, you would read this as 0 is less than x, which is less than 7, or 0 is less than x and less than 7. When you graph it, it'll look like this. This is an and inequality, so there'll be an overlapping area, 0 and 7. X is less than 7 when you read this part of it, and when you read the other part of it, you have to read it backwards. X is greater than 0. Greater than 0. That's what your graph would look like. Get rid of -5 by adding 5. Do it to the left and to the right as well. So now we have 4 is greater than 4x, which is greater than 8. Then get rid of 4 times something by dividing by 4. Do it to the left and do it to the right. 1 is less than x, which is less than 2. Again, there's your compound inequality. Graph them on the same line. Zeros here, ones here, twos here, just to have perspective of everything. You read them separate. Read this one as x is greater than 1. You have to read it backwards. So greater than 1. And read the other one. You can read it the way it's written. X is less than 2. Less than 2. Again, you're talking about the overlapping area for both of those and inequalities. Writing these compound inequalities. Greater than negative 6. So greater than negative 6. Less than 6. Less than 6. It says, but less than 6. So if you look at this picture, you'll have negative 6 and you'll have 6. It'll be greater than negative 6, but less than 6. So you have an overlapping area here. You have an overlapping area. So it says write a compound inequality. This is the graph of the solution, but negative 6 is less than x, which is less than positive 6. That's your compound inequality. Again, you can read those as two separate ones. If you read just the right side of it, you'll read x is less than 6. And if you read just the left side of it, when you read it backwards, you'll read it as x is greater than negative 6. But that is your compound inequality. Same thing for this next one. All real numbers at least negative 6. So x is greater than or equal to negative 6. Notice how I read that one as I was writing it. And at most 9, x is less than or equal to 9. There's your compound inequality. Both of them written on the same inequality and graphed on the same graph. Negative 6, 0, and 9. X is, reading it this way, x is greater than negative 6. Greater than, or I should say, or equal to negative 6. Reading the other one just the way it's written, x is less than or equal to 9. Color it in, everything that way. One road in Rochester, maximum speed of 50. So x is less than or equal to 50. Minimum speed of 20. X is greater than or equal to 20. When you graph both of those together on the same line, you have 0, you have 20, and you have 50. Less than or equal to 50 looks like that. Greater than or equal to 20 looks like that. So when you write them, that's an and inequality since they overlap. 20x 50. This one says x is less than or equal to 50. Make it match that one. Less than or equal to 50. Make this one's facing that direction there. Make this one face the exact same direction. It's probably the easiest way to write your compound and inequalities. Okay, so this is an overlap. You can clearly see that this one goes this way and this one goes that way. So this one says x is greater than or equal to negative 4. This one says x is less than 2. So when we put them together, negative 4x and 2, this one's written in the order that it is here, so make it say less than 2. Make this one go in the same order. It's facing, it's pointing to the left, so make this one point to the left as well. Or just note that this reverses the order of these two and reverse the sign. X is less than negative 2. X is greater than or equal to 2. They're not facing each other. There's no overlap, so this is going to be an OR inequality. So x such that x is less than negative 2, if we're writing them in solution set, or, remember that's the symbol for or, x such as x is greater than or equal to 2. And 25 says all real numbers less than 3, so x is less than 3, and greater than 13. So less than 3, greater than 13. When you look at that on an inequality line, you have 3 and 13. Less than 3 is that. Greater than 13 is that. So there's no overlap. That's an OR inequality. So again, x such as x is less than 3, or x such as x is greater than 13. Anytime they're OR inequalities, you just write them side by side. Solve this compound inequality. So solve them separate. Get rid of minus 8 first. So 7x is less than negative 7. Get rid of 7 times by dividing by 7. X is less than negative 1. Don't reverse the sign. You divide it by positive. Get rid of plus 10 by subtracting it. So 10x is greater than 10. Get rid of 10 times something by dividing by 10 on both sides. X is greater than 1. So you have x is less than negative 1 and x is greater than 1. Look and see where they're going to be. If they overlap, it'll be an and. If they don't, it'll be an or. Less than negative 1, open bubble, everything that way. Greater than positive 1, open bubble, everything that way. So solve it and then graph it. So again, x such as x is less than negative 1, or x such as x is greater than 1.